Hello, welcome to your Lab 2 video walkthrough. I think you'll find this lab kind of fun and short, and we'll get through it, gaining a really good understanding of mean, variance, and standard deviation. So let's get into it. Remember, always right-click and save your lab file into a secure location. Here we go on OneDrive, downloaded it, and let's hide my floating meeting controls. Okay, so here's my lab. Remember, change your name. What are the objectives for this lab? They are to always write and organize statistical reports in a clear, readable format, and then use and apply those structures for handling data. So the structures we're learning in this course, in this lab, are mean, variance, and standard deviation. So it all starts with some data. So here's some data, 1, 2, 5, 8, 9. Here's some cool things we can do with our data. I should say, when we have a list of data, 1, 2, 3, 5, 8, 9, I can put a C in front to mean I'm storing this as a list. That's a really convenient way to put data. And you can look over here in my environment and see, hey, this data has a list of 1 through 5. This means I have 5 values in here. I could access any one of those points. I could say brackets 1, and that would give me the first point. Brackets 2 would give me the second point. Up to brackets 5 would give me the last point. This thing is called a vector. So things we can do with the vector, we can say, what is the length of the vector? By using length and then parentheses. So that is 5. Again, we saw there was 5 points here. That's the number of numbers that are in my vector. We could also do something like sum of my vector. What are the points added up? So 25. So here's another data set, data 2. Practice finding the length and sum of this data set. Something I want you guys to do. You're going to insert a code chunk, Control-Alt-I, and then you can just say length, parentheses, data 2, and sum, parentheses, data 2. And you can check it based off like just adding them up, make sure you think it's what it's supposed to be. Okay, so those are some nice, actually this will get us through a lot of the lab using these functions. So median. If we're looking at data 2, what's the median of data 2? The median is the middle point. So we would count from the sides, we would cross off. I'm gonna get my pen over here. I think illustrating the median is pretty good. Annotate. If you've never seen this before, the median says, hey, let's cross off either point in sequence. So that's the outside point. Now let's cross off the next point until we get to the middle. And so in the middle, there's no middle point. There's actually 2 middle points. If there was like a point in between, that would be the median. But since there's 2 middle points, we're going to take the average of them. 5 plus 7. We add them together, and the average of 2 numbers, we divide by 2. So that's going to be 6. So 6 is the median of data 2. So that's what I'm going to say. I'm going to say 6. Median is 6. 6. But there's also a function we can use to check. We can say median. And all functions are like this. We say median, parentheses, data 2. And so, in fact, it is 6. So we can check ourselves. Okay. Next is mean or average. It's our first measure of central tendency. Well, actually, median and mean are measures of central tendency. But the way we find the average of n numbers is we add them up and we divide by n. So n is the length of the data set. So we already know how to do that. If we want to add up the numbers in data 1, we say sum data 1. That's the sum. And if I want to find the length of data 1, find length. So it's 5, 25, and 5. So I could in one line, I could do this. I could say divide by length. So we get 5. So that's how we can do it by hand, but R is smart. It knows how to find the mean as well. We just say mean data 1, and it does it for us. So now your task is to find the mean of data 2, and then we're going to make another data set that's higher mean than data 2. What's the mean of data 2? 6. Okay, I want to try to find a data set that has a higher mean than data 2. And then I want to prove it has a higher mean. So I'm going to put some values in here. What should I put? Maybe I'm going to put 1, 2, 3, 4, 5, but then I need some big numbers, maybe 100, 200. Let's see what the mean of this is. Indeed, this has a higher mean than data 2. I've just made the numbers bigger. And now let's make another data set with mean 10. How can we prove that it has a mean 10? This is going to be challenging. I want to make sure the middle number is 10. So there's different strategies you can use, and I want to see what you guys can figure out. See if you can come up with a data set with mean 10. Okay, and so then we have variance. Variance is this complicated formula, but in short, it says, how do we measure how far apart our data is spread? So let's do this with data 1. Here's data 1. I'm going to do it by hand for you guys to see. Maybe I'll do blue. So this formula, what this means is we take the first point minus the mean, square it, add it to the next point minus the mean, square it, and so on until I get to the last point minus the mean, square it. So what was the mean of this data set? X bar is the mean. I think we found that to be 5, right? Okay, so we would say x1 is 1 minus 5, square it. x2 is 2 minus 5, square it, plus x3. Oh, let's see if I can erase this. Running out of beautiful space. 5. x3 would be 5 minus 5 and square it. x4 would be 8 minus 5 and square it. And x5 is 9 minus 5 and square it. This should say 5 here. So let's type that in. Let's see what we get. We could do this all by hand. And this is the first time I'm going to have, the only time we're going to do it by hand. I'll say 1 minus 5, square it. This square is shift 6. And then plus 2 minus 5, square it. I can make this bigger for you guys. Plus 5 minus 5, square it. Plus 8 minus 5, square it, and 9 minus 5. Okay. That's the top of my fraction here. Right here. So now I still have to divide by n minus 1. So what was n here? N is the length. That was also 5. So n minus 1 is going to be 4. So now I have to take this whole thing and divide it by 4. And that'll give me my standard deviation. Big formula. So in a nutshell, what this does is it looks at the difference of each point from the mean. We're -4 from the mean. We're -3 from the mean. 5 is at the mean, so it's 0 from the mean. We take that difference, we square it, we add it up, and then we divide by 1 less than the sample size. So there's a formula for the standard deviation. Now, we could be clever. If we wanted to do this in a faster way, we could say, what if I just take x data 1 minus 5? What do you think that'll do? It takes all my data points minus 5. So this is 4 from the mean. That's 1 minus 5. 3 from the mean. That's 2 minus 5. 0, 5 minus 5, and so on. So that's already all these terms, the difference of all the terms. Then I can square it. Now I squared that 16, that's this term. The next number is this term, 9, you see the correspondence, and so on. So what I could do is I could add these up all in one go, 50, and now I could divide by n minus 1, 4, and I get the same thing. Oh, sorry, I misspoke. This is not the standard deviation. This is called the variance. We'll get to the standard deviation in a bit. So the variance is this number. So that's how we can find the variance. And I want you to have an understanding of what we are doing when we find the variance. We're going to be using this idea a lot. So the way R can find the variance is just VAR data 1. And you see we get the same value. So next, we're going to do some scientific exploration of what we think the variance of data 2 is going to be. So here is data 1. Variance is a measure of how far apart it's spread. So data 2 is spread apart even more. Notice that? -2 to 15 is a wider spread. And so if we find the variance of data 2, I'm going to expect it will be bigger. See what you get. So 9 through 12, those are kind of exploration questions. We're going to ask you, if we add 10 to every data point of data 1, so here's what that is. Data 1 plus 10, do you think we're going to have a different mean and variance? How will it change? I'm going to guess the mean will change. It's going to be like a bigger center, but the variance, that measures how spread apart it is. I'm going to guess it won't change. So you can check. Data 1 plus 10, notice it pops up here. I can choose that. And I can just say, actually, I want the mean of that. Find the mean of data 1 plus 10 and the mean and the variance. Data 1 plus 10. Yeah, and so that way I can look at what the mean is and the variance is, and I can see, does it match my hypothesis? And test whether it matches. So this kind of exploration will help you understand better what these concepts are doing. So finish these 9 through 12, and you can definitely pause the video. Please keep pausing it. And when you're ready, we can look at the standard deviation. The standard deviation is the square root of the standard deviation. And we always use S to measure standard deviation. And you can see why now that we use S squared to represent the variance. So what is my standard deviation of the data 1? Well, we found the variance of data 1, right? It's 12.5. So now we are going to take the square root of that. We're going to say square root of 12.5. 3.95 something. Okay, so you could do it that way, or the fast way to do it is just say SD for standard deviation, data 1. Oop, error because I put an underscore there. There you go. So you can see it's the same thing. So now I will leave you to finish 14 through 17 on your own now, and 18 is bonus. So you're creating new data sets and testing whether you think they will change. Okay, so good luck. Come to class with any questions, anything you get stuck on this lab, and we'll go from there.